All right, guys, so here's your video lecture for Monday. Again, I mentioned this last week that I'm gone. Camping up in the mountains for a family reunion up in Estes Park area. So this is a little bit easier stuff to do with matrices. It's not the row echelon, it's not solving systems. It's really just playing around with matrices. How to add them, how to subtract them, how to do two different types of multiplying. If you notice on my little list here, there is a multiply matrix by a scalar. When I say scalar, I want you to just think of that as a number. So if I give you 5 times a certain matrix, let's call that matrix A, what does that mean? Or let's say 5 times the matrix 2, 1, 4, 7. What does that mean? That's one way to multiply. Another way to multiply is if I have two separate matrices, and I'm going to multiply. Let's say this is 1, 2, 3, 4. Times 5, 6, 7, 8. Okay, there's two different types of ways to multiply, and that's the big part of today, is teaching you really how to multiply two matrices together. And along with multiplying two matrices together, that will help us understand what it means to find an inverse of a 2 by 2 matrix. So let's take a look at these things, starting with organizing what a matrix is. So remember, a matrix helps organize data into rows and columns. And when you decide to call something a 3 by 2, so let's highlight the number 3 throughout all of this. So there's a 3 because there's 3 rows, and the way you see that is 1, 2, 3 rows. And then there's 2 for 2 columns, 1, 2. So 3 rows by 2 columns, that's the order. That's the way you call it. It's the order. Now the order is another name, as it always seems there's so many names for different things. Order is another name for dimensions. Now when we're calling things, we can look at A11. So when I'm looking at A11 being 3, that's this guy. And A32 being -3 is this guy. Now the first one's kind of hard to see or understand what the 1 and 1 represents, because both it's 1, 1. But the A32, it's easier for you to see that this is A row 3 column 2. So the first number is always your row, it's your first, and the second number refers to the column. So when I want to do A12, A12, that means row 1, column 2. Row 1, column 2. Row 1, column 2 is that guy there. Okay? That's just a way to talk about the size of a matrix. When I say a 3 by 2, that means there's 6 numbers in it, because 3 times 2 is 6, and it's organized in 3 rows and 2 columns. So, operations that I want to teach you today: how to add and subtract, how to do matrix scalar multiplication, and matrix multiplication. And throughout my examples, I'm going to try and keep it highlighted as always yellow when I'm doing the adding, subtracting part. We'll go green for the scalar multiplication, and we'll go blue for the matrix multiplication. So you can refer back to these notes, which I'll post as well online. So you'll see the video and you'll see these notes. Okay, so here, I want to add. So this example is a yellow example, and I want to add. And the whole key to adding is you have to match up to start. So this is a 3 by 2 matrix, 3 rows, 2 columns. And this guy is a 3 by 2 matrix, 3 rows, 2 columns. So your answer is also going to be a 3 by 2. And it is this simple. You pattern match. You're looking at the 3 guy and the -7 guy. The top left, add them. Since it says add, 3 plus -7 is -4. If I want to add 0 and 4, I get 4. I can add 1 and 2 and get 3. I'm going to run out of colors here, I feel. -5 and 0 gets you -5. 2 and 1 gets you 3. And one more color here. 3 and 8 get you 11. You are literally just adding each corresponding part to the matrix. So top left goes to top left, top right goes to top right, and whatnot. And the whole time, our operation that we're doing for each number pair is you're adding them up. Okay. So here, when you subtract, I think you can see the idea that you first want to check that this is a 3 by 2. This one's also a 3 by 2. When you subtract them, you're going to further get a 3 by 2. And the whole key to this is subtraction. So again, you're just going to pair up number by number, number by number, number by number. So this time let's try and do it with some highlighting. 3, -7 goes there. 0, 4 is going to go there. 1, 2 goes there. -5 and 0 will pair up there. Running out of colors, even when I highlight. Those pair up. And lastly, you'd get one like the 3 and the 8. Now this time, each one, you're just doing it basically 6 times. Take the greens, subtract them. 3 minus a negative creates a 10. 0 minus 4 is -4. 1 minus 2 is -1. -5 minus 0 is -5. 2 minus 1 is 1. And 3 minus 8 is -5. Okay. Now, the nice part of this is, even though these are quite simple, you can still check your work on a calculator. So what you would do to do the calculator part is inside the matrix section. So we're going to turn it on. I hope I can turn it on. And give me a second. I'm going to hit pause and I'll fix this real quick. All right. So to enter a matrix, you do second matrix. All of these are capital letters getting ready to name a matrix. And we're going to name the first guy will be our A. And our second one is going to be B. And we're going to see if we can enter the data. So on A, you go over to Edit. You tell it it's a 3 by 2. And you're going to set it up. So all I'm doing is entering the data. It's kind of like entering in a list when we used to do the regression stuff, when we were trying to find cubics and logistic models. We're just putting in the data here. When you hit enter, it hops to the next cell. So I have matrix A set up. It's a 3 by 2, and I just copied in the data from it. Okay. I can go back to second matrix, go to edit, and we're going to go down to B. We're going to make this guy 3 by 2 as well. Okay. And I'll put in -7, 4, 2, 0, 1, 8. Okay. Now, when you look back at your matrix list, I have A as a 3 by 2 and it has the stored data, and I have B as a 3 by 2 and it's stored data. Example 1 and 2 were the exact same matrices. I just added them and I just subtracted them. So here, if I want to subtract and verify that A minus B gets me this new matrix, I'm going to go to matrices, I'm going to do A minus B, enter. I have 10, -4, -1, -5, 1, and -5. So from that, if I go into my snipping tool, I'll just store that in here for verification. And on the other one, which was here, it was the same two matrices, I just added them. So on my call, I can go second matrix, first guy, second matrix, second guy, and when you add them, you can check your work. So I did those correct as well. And oops, let's do a new one here. Here we go. Okay, so adding or subtracting should be very straightforward. The next one, you try to type in. So I have this as a 2 by 2. This is a 3 by 2. But the issue is Well, what's the dimensions of the new matrix? Because I can make an argument that maybe top left goes to top left, top right goes to top right, bottom left maybe goes to the next guy below purple, and green goes to green. But here's the issue. Right now, I have this huge issue with these guys here. I don't know what to do with them. They don't pair up. I had purple to purple, yellow to yellow, red to red, green to green, but the others don't pair up. So what happens here is you can't add or subtract. Dimensions have to be the same. Okay. What will happen, let me show you on the calculator what will happen if, let me just enter a new matrix as C. Now let's make this one 2 by 2. Okay. And let's say it's negative 2, 7, 5, 0. Okay. So if I tried to add, let's say C and A. So if I try and add the C guy plus the A guy, what happens is this, dim mismatch. So I want you to know that that's what happens. That's the error. That's what the calculator is trying to tell you if you're adding things that don't have the same dimensions. So it says dim mismatch because you're not matching. This mismatch idea, that mismatch idea is the whole thing of that's a 2 by 2, that's by 3 by 2, they don't pair up. Okay? All right, let's look at this next one. So this is going to be the green style, which is called scalar multiplication. So scalar matrix multiplication. This is where you have one number and one scalar. Or sorry, one number and one matrix. So the scalar part is that piece, and the matrix part is that piece. Okay? So what happens here when you multiply? So this is a 3 by 2 dimension. That's just a number by times 3 by 2. So what happens is you're still left with a 3 by 2, but it's this whole idea of distribute. So distribute your scalar to every, let's say, number in matrix. So that negative 2 is going to go to the 3. It's going to go to the 0. It's going to go to that, there, here, and here. You're doubling every element in the matrix. So if that's another way to write it, you can say that. Double every element in the matrix. So when you do it, you got negative 2 times 3 is negative 6. Negative 2 times 0 is 0. Doubled, 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 doubled. Every number that I originally started with is now doubled. So if I just highlight as a whole unit here, all of these yellow numbers are doubled into this category. So let's take a look at that if we were looking on the calculator. Now I kind of forget which guy is this matrix. 3, 0. Okay, that's matrix A. So on my calculator, I'm allowed to do this on the calculator. Negative 2 times A. That's what my calculator will do. So when I do this, negative 2 times A on the calculator, I go negative 2, number first, then I pull up the matrix, A, and it grabs it for me. Every guy is doubled. So I'm going to come here, snip this so we can see this in, oops. Let's do one more here. Oops. There we go. Okay. Paste that in, just like that. Okay. So that's scalar multiplication, which leads us to one where it's a combination of a scalar multiply and adding or subtracting. So this, if you're looking at the example again, it's yellow because of this, but it's also green because of the 3a part and the 2b part. So when I want to organize this, I would go something like 3, 4, 1, 3, 2, minus 2, 0, 4, negative 3, 1. Okay? And what's going to happen is this is a 2 by 2. This is a 2 by 2. So when I do my work, my final answer will also be a 2 by 2. Okay? Now, first thing, you're going to distribute the 3 to each part of that front matrix. And this becomes 12, 3, 9, 6. That's the first matrix. Now I'm going to distribute, and you can kind of think through this how you want. You can distribute the negative 2, or if you want, you can just distribute the 2 and realize later I'm going to subtract. So if you do it that way, I'm going to still say minus, and I'm going to set this up as 2, 8, negative 6, 2. So notice, I doubled everything in that second matrix, and I did nothing with the negative. I kept the negative outside to remind myself we're going to be subtracting black minus the purple. And when you set up black minus the purple, it's going to get finally one number. Now we're going back to the whole thing of pairing up. So when I pair up, I'll have the yellows subtract, gets me something. The greens will subtract and get me something. The blues will pair up, and the purples will pair up. And you'll get a 2 by 2 matrix. 12 minus 0 stays 12. 3 minus 8, negative 5. 9 minus a minus 6. That minus the minus becomes a plus. And 6 minus 2 is 4. And I think you could see what you would be typing in on your calculator. You would literally be typing in 3 matrix A minus 2 matrix B, and you could get it. So my matrices are different here. Okay, these are different than the A and B provided in this example. But the way you would type it in is 3 matrix A minus 2 matrix B. Now when I do this, I'm getting a 3 by 2 as my answer, and that's solely because my matrices both started as 3 by 2s. But the part I care about is making sure you know how to type it in. So I'll just snip that and throw it right in here for your reminder. Okay? All right, so we've done yellow examples, green examples, and a combination of yellow and green. Now, on the next video, I'm going to be solving this type of problem, which is matrix by matrix. Okay? It's a little bit more organizational skills and how you line this up. So open up the next video and take a look at that.